Hello everyone, I am Milind Dahirao and today I will explain you about the Cisco ACI architecture. So Cisco ACI fabric consists of three major components. First is your leaf switches, then second is the spine switches, and third is the epic controller. So the ACI fabric consists of these three major components: the leaf switches, spine switches, and the epic controller. So epic stands for Application Policy Infrastructure Control. Only Nexus 9K switches supports the ACI, and apart from the Nexus 9K switches, the 2K switches also supports the ACI. But then the 2K switches are just the port extender. So and what is a port extender and how it works, that I will explain you in a separate video. But as of now, consider that only the Nexus 9K switches supports the ACI, and in the Nexus 9K as well, we have two different operating system, or the image that what we call as. The first image is the NX OS. That is the traditional way of configuring the Nexus switches using the CLI command line interface, and the another image is the ACI image. The switches, the Nexus 9K switches having the ACI image, those switches will only be able to participate in the Cisco ACI fabric. The other switches like the Nexus 9K switches with the NX OS operating system will not be able to participate in the Cisco ACI fabric. And there are the 5 different product family in the 9K. We will just quickly check the different product family of the Nexus 9K switches. So if you search in a Google Cisco Nexus 9K compare models, you will see this URL, and if we click on the Cisco URL compare model Nexus 9000 series of switches, let's just wait for a couple of seconds for the page to load. So we have 5 different product family in the Nexus 9K: 9200, 9300, 9400, 9500, and the Nexus 9800. So these are the 5 different product family we have in the Nexus 9K. If we check this Cisco Nexus 9200, then 9200 does not support the ACI, because if we just search with the operating system, then it is saying that Cisco Nexus 9200 platform supports the NX OS operating system. So it supports only the NX OS, and as I mentioned earlier, the NX OS switch will not be able to participate in the Cisco ACI fabric. So 9200 switch doesn't support the ACI. If we check the 9300, which is the next model in the 9000 series, then in the 9300 we have the other couple of models as well: 9300 with 10 Gbps T switches, then the 1x10 by 25G fiber switches, and the 9300 40x100 gigabit Ethernet switches. So if we check this switch, the 9300 switch, which is the 10 Gbps T switch, then you will see that on this switch the operating system supported is the NX OS and ACI. So this switch will be able to participate in the ACI fabric. Now again, there is no separate command to convert the switch into the ACI fabric capable switch. It's just the OS image. So if the switch is having the ACI image, and if we boot that switch with the ACI image, then it will be able to register into the ACI fabric. And what is the role? What is the usage of that switch, whether it's a leaf switch or spine switch? So if you see the usage here, it is showing the usage as the ACI leaf. So this switch will function as the leaf switch. So if you see all the different models of the 9300, that can function as the ACI leaf switch only. It will not be able to function as the spine switch. So if you see the another model of the 9000 series, which is the 9400 series of switches, if we see the compare models of 9400, let's just give a couple of seconds for this page to load, and then you see here the operating system, which says that the operating system is the ACI and NX OS. So 9400 series of switches can participate in the ACI fabric, and their usage can be this switch can work as a ACI spine on the leaf switch, right, in the ACI image. So this switch we can register as a leaf switch or the spine switch as per our requirement. So while registering this switch on the ACI fabric, you will have a drop down option, and you need to select as per your requirement whether you want to register this switch as a leaf switch or the spine switch, and then this switch will be registered to the ACI fabric. So that is the detail about the 9400 series of switches. If you see the 9500 series, so 9500 is a chassis based switch. If we see the different model of the 9500 series of switches, then here this is specifically a spine switch. The ACI support, you can see that it is mentioned as a yes. So this switch will be able to participate in the ACI fabric, and this is specifically a spine switch because it's a chassis based switch. So this switch can function as a spine switch in the ACI fabric. If you see the another model of a switch, which is the 9800 series of switches, so compare the Nexus 9500 some modules, the 9800 series of switch. So compare the Nexus 9800 series of switches. The 9800 series of switches, the operating system supported is only NXOS. So the 9800 series switch will not be able to participate in the ACI fabric, and you will be able to only be able to configure this using the traditional way of configuration using the CLI. So that's the quick model comparison of the 9000 series of switches, guys. The next is what is leaf and what is spine. Right? So we discussed about the three major components of the ACI architecture, which is the leaf, spine, and epic. But then what do you understand by the leaf switch and spine switches? So leaf switches are at the access layer and the spine switches are at the aggregation layer. So let me quickly open a network diagram to explain this in a more better manner. Cisco ACI fabric. So the leaf switches are at the access layer and the spine switches are at the aggregation layer. The ACI adopts the class architecture. The class architecture means the two-tier architecture rather than the three-tier architecture. So we will just have the aggregation layer and the access layer instead of a three-tier architectures. So there are the certain model of a switches. We just saw that there are the certain model of a switches which can function only as a leaf switch, and there are the certain model which can function as a spine switch. But then there are the certain model which can function as a leaf or the spine. So depending on your requirement, while registering those switches into the ACI fabric, you can select from the drop down and then you will be able to register those switches on the ACI fabric. So the leaf switches are the switches where we can connect the endpoints, or your epic will be connected to your leaf switches, the endpoints like your machines, the servers, and the third-party devices, maybe the firewalls, or maybe this L2 switch, the L3 device like a router that we can connect on a leaf switch. The spines are acting like a east to west communicator. So they are basically used to connect the multiple leaves together. All the leaf switches will connect to the spine switches, and we will have the redundant spine switches basically. So we will have two spine switches for the redundancy purpose. The communication between the endpoints. So if you have an endpoint connected on a leaf 101 and a leaf 104, then the communication between the two endpoints will happen by the spine. So that's the basic idea or the understanding of the leaf and the spine switches in the Cisco ACI fabric. Now the advantages, what are the advantages of a class architecture? As we discussed, the Cisco ACI fabric adopts the class architecture. So there are the certain advantages of a class architecture. So the first advantage of the class architecture is high availability. So that's the first advantage of the class architectures. So high availability means we have two spine switches and the leaf switches will connect to both the spine switches, so that the spine switches works in a high availability. That is the first advantage of a class architecture. The second advantage of the class architecture is the scalability. The second advantage is scalability. So if we want to add more number of endpoints, we can simply add more number of the leaf switches, and we can connect those leaf switches in a redundant fashion to both the spine switches, and we can simply add the more number of leaps endpoints to your networks. So scalability is one of the advantage of the class architecture. The third advantage of the class architecture is the one hop reachability. Because we just have the access layer and the aggregation layer, the one hop reachability is the another advantage of the class architectures. The third important device, let me just clear my whiteboard. The third important device what we have in the Cisco ACI fabric is the APIC control. So this is for the management of the ACI fabric. So Cisco uses the C-series server, and on top of that it installs the APIC image. So when we order the APIC from the Cisco, so Cisco will give you the C-series server, and on top of that it will install the APIC image and it will deliver. So let me quickly open a network diagram to explain about the APIC controller. So this is the diagram or the overview or the picture of the APIC image, how it looks like. So we have a 2 into 10 gig SFP plus ports, and these ports to connect to the leaf switches. So if you see here the fabric links, right, this ports will connect to your leaf switches, and these are the 2 into 10 gig SFP plus ports. We have a 2 into 1 gig copper ports, and this is for the out of band management. So basically one port will be active at the same time, another port will be in the standby mode, and this is for the management of the APIC. Basically at the end this is a server, right, and it has the CPU, memory, and then the other parts as a normal server, and of course we need to manage this server, and that's why we have the SIMC port. If you see here we have a CIMC port, which stands for Cisco Integrated Management. So SIMC is a software inbuilt inside the APIC and which is used for the management of the hardware of the server. So tomorrow if the CPU is faulty or the storage is faulty, how we will come to know, right? And that's why we have a SIMC port, that is for the management of the APIC server, because at the end the APIC server it's a server. So that's why we need the SIMC port, which is the Cisco Integrated Management Server. And we have this USB port for the connectivity to your mouse, the keyboard, and then we have a display port as well for connecting to your monitor. So this is the kind of an architecture of the APIC controller and the Cisco ACI architecture. Then what is the design considerations that we need to follow while designing the Cisco ACI architecture? There are very important considerations while designing the Cisco ACI fabric. So let me open a network diagram to explain this in a better manner. Just give me a couple of seconds. So there are some design considerations while designing the Cisco ACI architecture or fabric. The first is the leaf to leaf should not be connected. Okay, the spine to spine should not be connected. Leaf to spine should be 40 gig only. APIC can be connected to leaf only. We should not connect the APIC to the spine switches. And APIC to the leaf connection should be 10 gig connected. One APIC can be connected to maximum 2 leaf switches. Okay, so one APIC will be connected to maximum 2 leaf switches for a redundancies purpose, and spine cannot be connected to anything apart from the leaf. So the spine switches will only connect to the leaf switches and it will not connect to any other device. The leaf can be connected to the spine as well as to the APIC and to the external device. Now in this case the external device can be your endpoints, your ESXi host, your physical servers, your switches, maybe Cisco switches, non-Cisco switches, or maybe your firewalls, right? Maybe the Cisco firewalls or the other vendor firewall. So this is the kind of an overview, guys, in terms of what is the Cisco ACI architecture.